Once we know the value of the equilibrium constant K, whether it's a Kp or a Kc, either way, once we know the magnitude, we're going to know something about the chemical makeup of the reaction when it reaches equilibrium. So for the example that we were talking about in the last video, Kc was 6 times 10 to the fourth. And remember, K is a fraction of products on the top, reactants on the bottom. The only way for a fraction like this to be much greater than 1 is if we have a large number on the top and a small number on the bottom. So when K is much, much bigger than 1, we know that the products at equilibrium will be more prevalent than the reactants. So we call this a product-favored reaction. The other extreme we're going to look at is when K is really, really small. If K is much less than 1, and remember, K always has to be a positive number because we're talking about molarities or pressure in units of bar. So when K is really, really small, that means our fraction is made up of a small number on the top and a big number on the bottom, which means the reaction favors the reactant side when it reaches equilibrium. Those are the two extreme cases. If K is not really, really big or not really, really small, then those intermediate cases, you're going to have a lot of both reactants and products when it reaches equilibrium.